Good morning, class, and welcome to our video on volume of prisms. In the last video, Mr. Eberhardt reminded you what a prism was and talked about finding the surface area, which is the area along the outside of the shape. He talked about it as being the amount of wrapping paper it would take to cover the shape. So today we're going to talk about volume, which is the space inside of the shape. So if you haven't done so already, please fill out the topic essential question, and we'll begin. Okay, remembering back to our area formulas, the area of a square rectangular parallelogram was taking the base times the height. We talked about how it doesn't matter which is the base and which is the height, or if you call them length and width or base and height, it means the same thing. You're just taking the two dimensions of your square or rectangular parallelogram and you're multiplying them together. Okay. For the area of a triangle, it's very much related because we talked about how a triangle is really just half of a rectangle. So if you took a rectangle with this base and this height, cut it in half, you would get this triangle with that same base and height. So the area of a triangle, we would do base times height, and then divide by 2, because the triangle is only half of the rectangle. So that'll become important in what we're going to talk about today with volume. So keep that in the back of your mind as we go forward. Okay, if we talk about volumes of square or rectangular prisms, because they have 3 dimensions instead of 2, we're doing the same thing as we did before. We're just multiplying all the dimensions together, but here there's 3 numbers. There's a length, a width, and the height. So again, it doesn't matter what you label what. You're just taking the 3 numbers and multiplying them together. Okay, remember, order does not matter with multiplication. Okay, we'll get to the volume of a triangular prism a little bit later, but let's start with just square or rectangular prisms. Okay, and also because we're multiplying 3 dimensions, a length, a width, and a height, the volume is going to be measured not in square units, but in cubic units. Think about the space required to fill up a 3-dimensional figure. You can't fill it up with 2-dimensional squares. You would need 3-dimensional cubes to fill up that area. Okay. So for our first example, let's consider this shape. The shape looks kind of like a 4x4x4 Rubik's Cube. So if we think about how many little squares it would take to create this shape, we can think about starting with the front layer. So we start with the front layer. We see the front layer has 4 rows of cubes stacked 4 high. Okay, so it'd take 4 times 4, or 16 cubes to make one layer. And then because it has depth too, there's 4 layers. Each one of those layers would have 16 cubes to make that layer. So there's 16 cubes here, and then multiply that by 4 because there's 4 layers, each with 16 cubes. So 16 times 4 gives me 64 units cubed. That tells me it would take 64 of these small cubes to make up that shape. Again, notice the order doesn't matter. We had 4 times 4, and then we multiplied by 4 again. So we just ended up multiplying these 3 dimensions, and it doesn't matter what order we do it in, whether the numbers are the same or not. So let's do a couple examples where the numbers are not the same. So this one's not a cube, it is a rectangular prism. I take the 3 dimensions, 6, 4, and 7. I'm going to multiply those together. So 6 times 4 is 24 times 7. Do the math real quick. Gives us 168. So it's 168. These are in centimeters, so it's centimeters cubed. Okay. Looking at this next one, we got bigger numbers, but the process is the same. We're going to multiply 27 times 40 times 56. Doing the math on that gives us 60,480. Again, this is volume, so our units are going to be feet cubed. Feet cubed. Okay. I will pause the video here to let you try a couple of those before we move on to triangular prisms. Okay, moving on to triangular prisms. Remember that a triangle is half of a rectangle, and as it turns out, a triangular prism is half of a rectangular prism. So if we think about the triangular prism that has this width, this length, and this height, you can see that it is half of the rectangular prism with that width, length, and height. So we just have to do the same thing we did before. Okay, when we took the area of a rectangle and divided by 2 to get the triangle, now we're going to take the area of the volume of a rectangular prism and divide it by 2 to get the volume of the triangular prism. So let's try a couple of those. If I see this prism here, I got my 3 dimensions, 13, 4, and 2. Please note that I am using the dimensions that are perpendicular to each other at right angles. I'm never using the slanted side as a dimension. Okay. Just like with triangles, the base and height needed to be perpendicular to each other. All 3 sides need to meet at right angles in order to be the 3 dimensions. So I do 13 times 4 times 2. Doing the math on that quick. I get 13 times 4 is 52. Times 2 is 104. And then because it's a triangular prism, I have to divide that by 2, which gives me 52 centimeters cubed. Centimeters cubed. Okay. All right. Looking at one more down here. Got a triangular prism that's 5 by 6 by 9. You notice I'm not using the slanted sides at all for dimensions. 6 and 5 are my base and height. There's my width. So 6 times 5 times 9. 6 times 5 is 30. Times 9 is 270. Then because it's a triangular prism, I have to divide that by 2. 670 divided by 2 equals 135 centimeters cubed. All right, I'll give you a chance to practice a couple triangular prisms before we conclude our video. Okay, hopefully those went well. Don't forget your teacher is available between the hours of 10 to 12 and 1 and 3 to answer any questions you got. Thanks. See you in the next video.